Hello everyone, welcome back to 5.4. Today we're going to talk about the modeling reducing balance and also recurrence relation with. Um, so we're going to using the formula by reducing balance and depreciation as recurrence relation. Um, so we have a new 15,000 painting price of the company, and as we have an example before. Generate the depreciation schedule, which is we're going to use in recurrence relation for 5 years, and for the work price. For this question, we actually need to know what is actually depreciation rate. So we know the ratios, which is 20%. Uh, so once we have the rate, and then we can just say R equal to 1 minus the R divided by 100. So what does that mean is 20 divided by 100. So I can just say that equals 0.8 is your depreciation rate. Sorry, that equal to the what's that? What the capital R is representing the rate for the reducing balance. Sorry. So once you have that, Vn plus 1 equal to R multiplied by Vn. Vn plus 1 equal to 0.8 multiplied by Vn. And V0 equal to $15,000. That's the recurrence relation. Okay, for question B, which is we're going to try to figure out the state of 5 years. So how about using the our CAS calculator, which is we can analyzing that for each individual part. This one we can say pension, which is paid. So first year will be $15,000, and second year equal to 0.8 multiplied by A1. So once you have money, data, and fuel, first 5 years. So first, second, third, fourth, first 5 years, and control equal. I have no idea this is equal to. Yeah. And if you figure out that's how to make the exact values, and you could using the exact values. So this is a V1, V2. So V0, V1, V2, V0, V4. So once you have the numbers, and what you need to do is you just substitution into the calculator and answer the question we had. Well, I should write down V0, V1, V2, V3, V4, and V5 equal to 4,915.2. That's it. And you're drawing the numbers, which is control dot. We're going to the statistics. So what we do is just set that one P, and the value is, oh sorry, I forgot to put the value on V, maybe not C, V or C, Q. So 0, 1, 2, 3, 4, 5. Yeah. So now what we have is we have Q. So this is the curve functions, and if you want to connect the line, so basically this is how you find out to see the line x1 line parts. So this is how you draw in the graph, is the reducing the balance as the fundamental part. Hopefully that kind of makes sense. So that's how you draw in the graph of C as well. So that will be finished all the questions. So question 2, so which is kind of similar, but this time we're gonna using the previous year for values, and they're changing the flat rate and cost price per buying the 30%. First thing first, we need to know what's the flat rate, equal to 20%. So, what's the depreciation money? Well, equal to 20% multiplied by $60,000. That will be your depreciation money per each year. So because of 5 years, so what we do is Vn plus 1 equal to Vn minus $12,000, and V0 equal to a $60,000. Yeah. Because of 5 years, right? So what we do is I'm using another document, which is we start with flat rate. So $60,000 and equal to A1 minus the $12,000. So let's try to find out how many years we're gonna have. So maybe we go with 5. Yeah. And this one will be later on using the Q, which is 0, 1, 2, 3, 4, 5. Yeah. So we don't need that. Yeah. And then so 5 years, that will be $12,000, pretty much. And that will become 0. So once you have 5 years, so after 5 years, become 0 price. Yeah. So now what we do is we're using the reducing balance. That equal to, first of all, we start with the flat rate is 30%, so which is 1 minus 0.3 over 100, so which is 30% over the 100, so which is that equal to 0.7. Well, we have that, and we're gonna have Vn plus 1 equal to 0.7 multiplied by Vn, as V0 equal to 60,000. So now we're using reducing balance for that, so we say R $60,000 and equal to 0.7 multiplied by the C1. So we're reducing that fill and keep going one more, fill again, and once we have that, and then that's the 5 years looks like. So now what we do, we're going to control document. So list the data statistics. So what we do is got Q in here. And the first one will be using the flat rate and add a var value again. So you can see the different and plot so x1 reduce. So which is pretty saying the what we have is curve for the reducing balance, flat rate is a straight line. I'll screenshot that real quick. And that will be looks like that. So circle representing flat rate and square representing the reducing balance. Okay, so pretty much what we have for now. And now what we do is we're gonna using the reducing balance to find out our cost price and time since the purchasings. Um, let's have a look at these three. So, the printing price, which is working examples we have, is $15,000, and after 5 years, the cost at 15,000 new. So, which is we have is reducing the methods r equal to 1 minus r divided by 100, that equal to 0.8. That's what we have. And Vn equal to, we have a new price, which is V0 times r to the power n. So n equal to 5 years, and 0.8 to the power 5 multiplied by $15,000, that equal to V5. So V5 will equal to, if you're using the calculator, let's going back to the calculator, so control dot, 0.8 to the power of 5 multiplied by $15,000, and control equal, that will give the 4,015.2 as your 5 years, which is exactly we had from the previous video. So if you still remember the number, so that's how you calculate it, basically. Effective life. Now, what we do is we're using that to find how many years we have in the effective life, and normally we will say with the V0 equal to $8,000, Vn equal to $12,200, and now we're gonna find out r equal to 1 minus 25 over 100, which is 0.75. So Vn equal to V0 multiplied by r to the power n. So solve function equals Vn, which is the $8,000. So we see menu, algebra, and solve. Not factor, solve function. $8,000 equal to $1,200 multiplied by 0.75 to the power of n, comma n. So that's kind of crazy, but we press Control Enter, that equals 3.39. So, oh wait, sorry guys, I should be right. 1,200 equal to 8,000 multiplied by 0.75 to the n, comma n. Yeah, not. Let me rewrite. That's not right. So forgot to change my numbers actually. So what am I doing is I'm gonna change this one to 8,000 rather than 1,200, because that's not my initial value. That's better. And then press enter. Did I? Yeah, right? What? Oh, it's not 1.75. Sorry. What is going on? Must be something wrong with my typing. That's better. There you go. So that's a 6.59. So can I just say 6.6 years? So will be n equal to 6.6 years approximately, or 7 years in total. So this is how you're gonna calculate efficiency, and then you will find your number. Exam question, I want you guys to have a look by yourself, and then that's pretty much the same question we did in examples. Um, so especially the question 2 that will help you. Feel free to pause it and have a look at it. Go through the A, B, and C, and that will be help. Hopefully that all makes sense. I'll see you guys next time.